Now that we've looked at some of the basics of least common multiple, let's go ahead and look at some more challenging problems and how we're going to apply this to our discussion on fractions. Let's get into some more challenging examples. All right, if we look at example A, let's go ahead and factor 15. This is 3 times 5. $18. This is 2 times 9. And 9 is equal to 3 times 3. So these are the three factors that we want for 18. All right, what do we have in common? I have a 3. And now what's all the leftover stuff? We have a 5, a 2, and a 3. We want to go ahead and multiply this together. And again, remember multiplication, we can do this however we want. I'm going to multiply 2 times 5, gives me 10. And 3 times 3 gives me 9. And if I multiply that together, I do get 90. So 90 is our least common multiple. All right, let's try another one. Let's look at 9 and 12. If we factor 9, 9 is equal to 3 times 3. This is 2 times 6. 6 is equal to 2 times 3. Those are my prime factors, so we get 2 times 2 times 3. And now for our LCM, what do we have in common? We have a 3. What do we have left over? We have a 3 and we have 2 2s. And so now if we go ahead and multiply, 3 times 3 is 9, 2 times 2 is 4, and 9 times 4 is 36. All right, last one. 12 and 20. So if we go ahead and factor this, we get 12. We've already done 12, but just to do it again, we get 2 times 6, and 6 is 2 times 3. $20. This is 2 times 10. And 10 is 2 times 5. So we get 20 is equal to 2 times 2 times 5. Okay, for our LCM, what do they have in common? Let's see, we got a 2. We actually have a second 2. And what's left over? Our leftovers, we have 3 times 5. So again, let's go ahead and multiply this. I'm going to multiply 2 times 5, that gives me 10. 2 times 3 is 6. And if we multiply those two numbers together, we get 60. Now, if you are able to, and this just comes from practice, If you can recognize least common multiple without doing any math, then that's okay too. That's actually the goal. The goal is to be able to look at two numbers and know a number that is divisible by both, or know a number that is a multiple of both. And that's what we're going to kind of strive for. But if you get to the point where you are stuck, then you can either use lists or preferably prime factorization in order to find least common multiples. All right, let's do a couple more examples. Now, this is going to be a set of 3 numbers. Now, as I said, there are 2 ways to find multiples using prime factorization. I'm going to show you the second method for these ones. For me, when I get into more than 2 numbers, I start getting lost with what they have in common and what's not common, and it just gets a little crazy for me. So let's go through the second method. All right, so real fast, let's go ahead and do these factorizations. If you want, you can look through the notes. We've already done these. 12 is 2 times 2 times 3. 18 is equal to 2 times 3 times 3. And 20 is equal to 2 times 2 times 5. Okay, so now what I'm going to do is notice here that they all have some numbers in common, some of them have other numbers in common, and then there's a bunch of other numbers just running around. And so the second method we can do is I'm just going to start with one of my numbers. So let's just start with 12. I'm going to put all of my factors for 12 in my LCM. And then I'm going to go down to 18. Now, if it's already there, we're going to skip it. If it's not, then we include it. So for instance, for 18, do I have a 2 in my LCM? Yes, we do. So I'm going to go ahead and ignore this one. Do we have a 3 in the LCM? The answer is yes, so I'm going to skip that one too. Do I have a second 3 in my LCM? The answer is no, so that one I do need to include. All right, 20. Do we have 2 2s in our LCM? Yes, we do. Do we have a 5? The answer is no. So I'm going to include the 5. And then I'm going to go ahead and multiply this together. So let's see what we get. I get 2 times 5 is 10. And 2 times 3 times 3, I've got it over on the side over here, this is 18. And if I multiply that together, I get 180. All right, let's try a couple more examples. Let's look at example E. All right, 5 is equal to just 5. 6 is equal to 2 times 3. And 35, if we factor that, we should get 5 times 7. All right, so let's go ahead and start out with a prime factorization. Let's see here. It doesn't matter which number you start with. So for instance, on this one, I'm going to start with my 35. Again, it doesn't matter. Why? Because I can. Okay, so let's come to our other numbers. 5. Is 5 already in our LCM? The answer is yes, so we can go ahead and ignore this 5. If we look at our 6, 2 and 3 are not in our LCM, so we want to go ahead and include them. And now if I go ahead and multiply, I get 5 times 2 is 10. 7 times 3 is 21. And if we multiply that, we get 210. And this is definitely an example where lists would be very tedious. Do you know how many times how many multiples you're gonna have to list out in order to get to 210 for our factors of 5 and 6? We're gonna have to list out about 42 possible numbers. And I don't know about you, but I think that's gonna be a bit of a waste of time. So that is one of the good things about using prime factorization. All right, last one. Let's try 10, 20, and 24. All right, so 10, this is equal to 2 times 5. 20, this is equal to 2 times 2 times 5. And if you do the prime factorization for 24, you should get 2 times 12, which is 2 times 6, which is 2 times 3, or 2 times 2 times 2 times 3. All right, so which number do you want to start with? Again, it doesn't matter. I'm going to start with the 24. I always like picking the one that has the most factors to start off with that way. Well, it has the most. All right, so if we come up to 10, let's see what we got. Do we have a 2 in our LCM? Yes, we do. We do not have a 5, so I'm going to include that. All right, if we come down to the next one, do I have 2 2s in my LCM? Yes, I do. So we can go ahead and ignore those. Do I have a 5 in my LCM? The answer is yes. So we can go ahead and discard that as well. And so now if we go ahead and multiply this together, I'm going to multiply my 2 times 5, we get 10. I get 2 times 2 is 4, times 3 is 12. And so if we go ahead and multiply this, we get 120. Now in terms of the problems when we actually get into fractions, we're not going to be working with problems that involve these larger numbers. I try to avoid them as much as possible just because I'd rather you know it for the little numbers. But just in case, yes, they do exist. You can have a denominator of 24. You can have denominators of 35. And so it's not that we can't do it, it's just that we have a tendency to stay away from it a little bit. All right, so now let's go ahead and look at some other problems. Okay, so now if we look at the next set of examples, we're going to bring in our fractions briefly. And so what we want to do is we want to find the least common multiple of the denominators in each set. And we actually have a special name for this. We call it the least common denominator because we use it so often. So basically when we do this, all we're going to do is exactly what we've been doing so far, but we're just going to have some extra numbers running around. So if we go ahead and look at our least common denominator, let's go ahead and do prime factorization. Eight is 2 times 2 times 2, and 5 is 5. So my LCD, if you notice here, they have nothing in common, And so my result is I just want to multiply my 2 cubed, or my 8, times 5, and we get 40. For example B, if we look at this, 6 is equal to 2 times 3. 14 is equal to 2 times 7. And my LCD, I have a 2 in common, and then my leftovers, my 3 and my 7. If we go ahead and multiply this, we get 2 times 3 is 6, times 7 is 42. So this is going to be one of the steps we're going to need in order to combine, or in order to add unlike fractions, is we're going to want this idea of least common denominator. All right, so what's the second thing that we're going to do? We've already talked about simplifying fractions. In simplifying fractions, remember, we divide top and bottom by the same number. Now, not only can we do division to the top and bottom, but we can multiply the top and bottom by the same number. So to write a fraction with an indicated denominator, we're going to multiply the top, the numerator, and the bottom, or the denominator, by the same number so that you get the indicated denominator. So let's see how this works. Let's start with 2/3. I want to write with a denominator of 15. So how do I get from 3 to 15? I want to multiply by 5. And whatever we do to the bottom, we do to the top, we get 10 over 15. Now this is going to be the one problem, or the one type of problem that you do where we do not simplify the fraction, because it did tell us that we want a denominator of 15. If we simplify, then, well, we're just going to go back to the original fraction, which is kind of pointless. So we're going to go ahead and stop. It has a denominator of 15. We're done. Let's try a couple more examples. Let's try 1/4. I want a denominator of 16. So how do we get from 4 to 16? We want to multiply by 4. And again, whatever we do to the bottom, we do to the top. 1 times 4 is 4. So our new fraction is 4 over 16. All right, a couple more. Let's try 5 over 3. Again, I want a denominator of 15. In order to get from 3 to 15, we want to multiply by 5. So we're going to do the same thing to the top. We get 25 over 15. And last one. How do I get from a denominator of 16 to a denominator of 32? We're going to multiply by 2. Whatever we do to the bottom, we do to the top. 7 times 2 is 14. So that takes care of this section. Now in this next section, we're actually going to talk about adding and subtracting unlike fractions. And so we're going to use all the things that we've combined in this section. Why are we trying to find common multiples? Well, we're trying to find common multiples so that we can rewrite each fraction with that denominator. Once we have our same denominators, then we can go ahead and combine them add or subtract them just like we did in the previous section. But for now, we're just going to go ahead and kind of keep our tasks separated. In the next section, we will combine all of these into solving problems that involve adding and subtracting unlike fractions. All right, that takes care of this section. Go ahead, do the homework, take a break, and I will see you again shortly.